So this stuff is aligning with 30-1 right now as well, that there is lots to know if you're going to draw a graph, okay? It's just not derivatives. It's just not the calculus stuff. In fact, probably 3/4 of the stuff you need to be able to draw a graph is from 30-1. The first derivative test and the second derivative test are the only things that are really out of 31. But your asymptotes, your x-intercepts, your y-intercepts, your like where do you start, where do you end, what does a even degree always look like, what does an odd degree always look like, that stuff, it's all evidence to be able to draw the final picture. But most of it comes from 30-1. So we're going to do a little bit of review of 30-1, and for some of you that just happened last week in 30-1, and some it was you last semester, right? Now, when you draw a graph, the first thing you want to look at is what's the degree, okay? So you want to state the degree of f of x and identify the shape of the curve. Now, where this is different from 30-1 is you don't have a graphing calculator, because if I asked you, where does the fourth degree with a positive coefficient on the fourth degree term, which quadrant does it start, which one does it end? Put it in your calculator and you'll see pretty quick. Well, you don't have your graphing calculator, so let's talk about for even degree. The curve opens up if it's positive and down if it is negative. Okay, so if you had, say, an x to the fourth graph, it'll start here, do whatever, right, and it'll end here. So because it's a positive x to the fourth, if there's a, like, say, I don't know, let's just put plus 3x to the 4, okay, that means it'll always start in quadrant 2 and end in quadrant 1. If that was a negative 3x to the fourth, that would be a reflection on the x-axis, but it would always start in 3 and in 4. For odd degree, so like x cubed, x to the fifth, the curve is rising when it's positive or falling when it's negative to the right. So as you read left to right, so this would be like a positive x cubed, right? It's rising the whole time as you go left to right. If that was a negative x cubed, it would be falling as you go to the, so that would do something like that if it was negative x cubed. Okay, so this is a big concept, because you're going to get the wrong graph if you mix up what the degree does. It's obvious. You're going to start in the wrong quadrant. So just one more piece of evidence, but that's something, again, that you should know from pre-calc. Next, intercepts. Okay, this you have done a lot in 20 and 30. Now the y-intercept, easiest thing to find is you let x equal 0. And these are pretty fast, right? Like if you had y equals x to the fifth plus 2x to the third plus da 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 da, you know, and then x plus 8, right? It's not a lot of math. You just put in your zeros, and so your y int would equal 8, right? That's the quick one. The not so quick one is the x-intercepts. This is where you let y equal 0. So then you would have 0 equals x to the 5th plus 2x to the 3rd plus, right, x plus 8. And you'd have to go and factor that to be able to find what would make that thing hit the x-axis, right? The zeros, the x-intercepts, the roots. And this is key, is how are you going to start this thing? Because you don't have your graphing calculator to look. You're going to have to, what are all the factors of 8? I'm going to put them into it, which is called the remainder theorem. I'm going to put it into it, what makes it equal 0, because I got to start somewhere, and I'm going to keep using synthetic division. Okay, so the 30-1s just wrote an exam on that, so they should know how to do that. So how do we do this? Okay, you want to use the factor theorem. And synthetic division. For higher degree functions, you may need to use the factor theorem. Oh, that's not good. It's there again. Okay, so now for second degree functions, when you get it down to that, because it may not be right off the bat, but you're going to be using the quadratic formula. Okay, now if above all fails, you can use the Newton's method, but I'm not going to show you Newton's method, so therefore I will not be giving you ones that will need it. Okay, so this is not in the curriculum, so we got enough stuff to do. Why put stuff in that we don't have to do? Okay, so I know where it's starting. I know where it's finishing. I know what's going through the x-axis. I know what's going through the y-axis. That gives me tons of information. But one thing we haven't been talking about is, you know, how high and how low is it going when it's making those turns and those twists? Well, so we're going to use the, oops, I've still got more room here. We're going to use the first derivative test for that. Okay, so differentiate and state the critical values when f prime of x equals 0. Because when the slope equals 0, it could be a max or a min. Okay, but not always, right? So this, of course, that would have a max. This would have a min. This would have nothing, right? So that's a max. That's a min. Oops. And that would be nothing. It's actually not nothing. It's an inflection point, but as far as max mins go for us, right? Because if it's going to go as a max, it must increase, then decrease after that critical value. That would increase, and then increase again. So that one's going from concave down to concave up, which is an inflection point. We're going to talk about that more later. Okay, place the critical values on number line and obtain the positive and negative signs. Show clearly where the function is increasing and decreasing, and state the absolute or local max min. And substitute back into f of x to determine the related points. The most common error is people substitute into the derivative. Now if you substitute in the derivative, you should get 0, right? So that would be a good indicator, but sometimes people go, hey, look, it's negative 7, 0. Okay, that's a min. That would be a min over there. That's cool. Okay, that's a max or a min. You'll only figure out the point, though, by putting into the... just a couple things that I was just, even want to put on the bottom of the, actually, let's go up to here, because even when we're looking at the degree, so go up to the top, a degree 2 always gives what shape? Parabola. Okay, degree 3, okay, will always give a 1, will always give a straight line, right? Is that what you're asking? Oh, yeah, sorry. Okay, 4 will always give you a W. Okay, doesn't have to be a nice W, right? But a W. And if you had degree 5, okay, it might be something that's just going to go like this, right? So that that runs through quite securely what you will be looking at for this this year. Degree 5's mean enough to do, but just kind of, you know, how many maxes, how many mins. Like degree 2, as soon as you're thinking, oh yeah, that's got to have 1 max, 1 min. Okay, a degree 3, there should be like a max and a min, right? Degree 4 would have a min and then a max and then a local. This would have here, 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 and here. Okay, so the max and mins are kind of always 1 less than the degree. Degree 1 would not have any max or mins. And degree 2 always have intercepts. No, not always, because you could have this as a... Okay. So, oh, and then sketch the curve. What do I want to say about that? Okay, so what kind of things do we want to put on? We want to put all intercepts. You want all turning points. Okay, use your knowledge of where the function is increasing and decreasing, connect the dots, extend the arms for both sides to determine infinity, right? So all this is given a bunch of information, draw a picture. And extremely logical stuff, okay? It's very, very logical. And it's like anything, I don't know how I lost. It's basically you're doing an investigation and you got to say what it looks like. You gather a bunch of evidence and then you piece it together. So these definitely take practice, okay? But the nice thing about them is that, like, a typical one would be out of like 10 marks, right? You can get your x-intercepts, right? Maybe you messed up the second derivative, but you got your first derivative. So it's there's a lot of places in here to get marks. And always keep an eye on the domain, because if it has start points and end points, it's going to have max mins that are different. Yes? We also deal with bounces as well. Yes. Yeah. Okay. In fact, okay, so a bounce, when does that occur? When you say have x plus 2 squared, that bounce would occur at -2. Okay, so -2, you should have a bounce that's there. And if you had x plus 2 cubed, you should have a squiggle at -2. And if you have, you know, x plus 2 cubed, or to the 5th, you're still going to have a squiggle there, right? But as you can see, your y-intercept would be different, right? So then it's going to extend it up more. But those things come into play, not as much, but it's just more stuff to know that helps you out. Okay, so we're just going to do 3 questions today, and you're going to get the gist of what we're looking for. And every day we're going to kind of build on one more thing. So we're always going to keep reviewing right from the first lesson every time we do a question. So sketch the following. Now, out of everything you know, what kind of shape should this be? Parabola. Okay, so once you get that in your head, like I don't know what, you write parabola, should be going up because it's positive. Like that stuff helps a lot. Now, let's do y-intercept, easiest one, right? So that's when x equals 0. So what would the y-int be? Okay, so we've got 0, -4. Okay, and then the fun ends there because then it's time to get down to the factoring. So x int, that's when y equals 0. So we want to go 0 equals x squared minus 3x minus 4. Okay. This one's kind of nice. 0 equals, how do I factor this one? This would be x minus 4, x plus 1. So we've got 4, 0, and -1, 0. And maybe I'm just going to put red around these because I am going to be putting those points down. Now some people may elect to keep putting the points down as they go, but then you don't really know what, what are my increments going to be on my graph? What if there's 108 as my minimum, right? And I went 1, 2, 3, 4. So I kind of gather all the information, but it is nice if you have a highlighter or something because you're going to have, it's going to look like a bunch of numbers all over a sheet, and you're going to be like, okay, whoa, now what do I do? So it's kind of like you found all this stuff, and then you threw it in this big pile in your garage, right? So, and then you got to look for it again. So you kind of want to be deliberate about, maybe I'll just put it in specific spots, so that's where I know where to find it. Okay, so we know where we're going through. Next thing, we know what shape it's going to look like. Let's find our max and mins, right? So we did that one. Let's do first derivative test. Okay. And this is where in math 20-1, which I'm going to be teaching them in a couple days, to find the vertex, they got to do completing the square. And completing the square is way more work than doing the derivative. So derivative is higher level learning, but it's actually less work. So what's the derivative? 2x minus 3. So when we are trying to find a critical value, we want to find out, well, when is the slope equals 0? Right? That happens at max and mins. And when does that happen? So CV equals 3/2. Now, you can't just go graph 3/2, right? So we need to find out the y value. Just make sure you take this and you plug it into here. And then we should get -25/4. Okay, and that's the same thing as 3/2, comma, -6 1/4. So that is what you would get if you did completing the square. You would get that vertex. And you know, oh, it's going up. You know it's going to be a minimum, right? So you just complete the square. So this is way faster than completing the square. So, yep. No, but it's pretty hard to graph negative 25 over 4, right? Put it in a decimal for yourself, or put it as a mixed fraction, whatever, right? Now, this one's a really easy one. So we can say, well, of course it's increasing on that side, decreasing, but we don't know that yet, right? Let's just presume for sure that we don't know it, so we'll do these all the same. I'm going to put 3 over 2 here. Okay, and then I'm going to test some values. So 3 over 2 is 1.5, right? So let's try 0. 2 times 0 minus 3 is a negative. Remember, we're putting this into the derivative, right? And then 2 would be a nice one here. 2 times 2 is 4 minus 3 is positive. So according to this, I am going down and then I'm going up. So this should be a minimum here. So we are increasing from 3 over 2 to infinity, and we are decreasing negative infinity to 3 over 2. Okay, now again, it's nice to learn these on easy graphs, because when you get to the other ones, you'll do the same exact thing, but you may not have that picture in your mind before you start. This one, hopefully you do. Okay, so I went by ones on the x, so 1, 2, 3, 4, negative 1, negative 2, negative 3, negative 4. I have to get down to negative 6 1/4, so that's why I'll go by 2s. So that's negative 2, negative 4, negative 6, negative 8, 2, 4, 6, 8. Okay, so you don't need too much imagination to figure out what tomorrow's quiz will look like. Okay, all I'm going to give you is this one question and say, sketch the graph. Okay? In fact, you're going to see that quite a bit on the next few quizzes. So, 1.5 and 6 1/4 is right down here. So this is 3 over 2, comma, negative 25 over 4. I am going through 0, negative 4. That's y int, right? Oh, and I should, this line that I did over here, I'm going to call this f prime of x, this line, because I want to get us into some good habits, because when I'm doing the second derivative test and I'm marking yours, I don't want to be guessing. Was this their first? Is there second? Because students get very creative, right? They'll do this, then they'll draw an arrow over here to this, and then you're turning to the back and stuff, which is cool. I get it. You don't know what it's going to, where if you're going to run out of room or not, but you got to be able to explain to me what you're doing. Okay, and then we've got negative 1, 0 here and 4, 0 there. So then we would draw it. And it should all kind of come together. Okay, let's speed her up a bit here and get a little bit more difficult. Now, any preconceived ideas of what it should look like? Start high and low, okay? And again, You don't have to have this perfect. This is just like, just to make sure that when you're graphing yours, it's following that. Okay. So the first thing you always want to do is write back to grade 10, and that's get your y-ints and your x-ints. So y-int, always start with that one because it's easy. Got to get going somehow. And that would be 0, -6. Your x-int, we want to do in y equals 0. So then I will be going 0 equals -x cubed plus 5x squared minus 6, oops, minus 3x minus 6. Now, if you remember the factor theorem states that if I put in a root, it should make this thing equal 0. Okay? Because that's what, if you ever look at a graph, anything that hits the y or the x-axis, y is 0. So if I put in a number and it makes it equal 0, well, it's a root. But where do you start? Okay, well, you start with this and this. Okay, so it is, you're going to do all the factors of -6 over all of the factors of -1. Okay, so this one would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all over plus or minus 1. Right? So you're going to try all those out. Now, is that fun? No. But it's the only way you can do it because you don't have a graphing calculator. If this was 30-1, I'd say put in your graphing calculator. See the one that goes through 2. Then go show me on the paper you tried to, right? And I'm like, oh, that's awesome. You got it, right? But you don't get to use your graphing calculator, so. But luckily, I have done some groundwork for you, and I found that 2 works. Positive 2 works, okay? Okay, so synthetic division can be 2 ways. You can put in the opposite of that and subtract, or you can put in the actual root. Now, if 2 is a root, what's one of the factors? X minus 2. Keep that straight. Don't get the root mixed up with the factor. Okay? So, I am going to now put 2 into this. So that is -1, 5, -3, -6. Okay, so let's do it. -1, 2 times -1, -2, 5 and -2, 3. 2 times 3 is 6. That gives me +3. 2 times +3, +6, and I get 0. Okay, if you didn't get 0, not good. Either you screwed up somewhere in the synthetic, or 2 was never a factor, and when you put it in the first time. So, guys, everything okay back there? So now I am dealing with x minus 2, comma, -1x squared plus 3x plus 3. Now, the -1 does change things a little bit in the front, so you'd actually have to find what 2 things add to 3 and multiply to be -3, right? Because it's always a times c. Okay, you're going to find that It's not nice. So we're going to have to use our friend quadratic formula. Yeah, you can take a guess. That'll go far for you. Okay, now that is on your study sheet, so let's just, or on your formula sheet. So it's negative b. Okay. Oh yeah. The notes I have, they took out a -1. So did I redo that? Oh yeah, I did. Okay, good. Okay, so that's -3 plus or minus the square root of 3 squared minus 4 times -1. A times c is 3 all over 2 times -1. That'll give you -3 plus or minus root 12 all over -2. And even for this one, I just went to 2 decimal places. So you'll get x equal -0.79 and x equals 3.8. Okay, so I guess let's do this. This is even a good thing to put a square around or a rectangle. And we've got 2, -0.79, and 3.8. We want to make sure, if it was me, I'd go make sure everything that I put in a box gets on my graph, or I'm probably going to draw the wrong graph. Okay, so we haven't even done any 31 stuff yet. That was all grade 6-ish stuff. No, quadratic formula is grade 6. Depends what school you went to, I guess. Okay, so let's do second derivative. Okay, y equals, what do you got? Oh, sorry, it's number 2, first derivative. Okay, so that's 1. So second, I want to do the first derivative. That's what I meant to do. What is it? -3. Okay. Take out a common factor. Negative. Okay, so we even have to factor this to get the zeros, right? Because we want to go 0 equals. So we're in what plus what is 10? What times what is 9? What are we getting? So 9 and 1. So negative 3x squared minus 9x, or plus 9x plus 1x minus 3. Put a set of brackets here. I can take out negative 3x, leaving with x minus 3. Here we'll take out a 1, leaving with x minus 3. So 0 equals x minus 3, negative 3x plus 1. So my critical values are 3 and 1/3. Okay, so I draw my line. I'm going to put 1/3 here. I'm going to put 3 here. Okay, so a good value to start off with is 0. So if I put 0 in, 0 minus 3 gives me a negative. And negative 3 times 0 is 0 plus 1 gives me a positive. So that's a big negative there. Okay, between 1/3 and 3, pick a good 1. 1 minus 3 is negative. Negative 3 times 1 is negative 3 plus 1 is negative. So I'll get a positive. Okay, be good to ourselves. Let's pick 4. 4 minus 3 is positive. Negative 3 times 4 is negative 12 plus 1. Negative. So I'll have a negative there. So I'm decreasing there, I'm increasing over this interval, and I'm decreasing there. Okay, so here I should be having a min, here a max. Ready to graph? No, we're not, because I couldn't graph my max or min yet. I have to find the y's with them. Remember to go into the original. Yes? Where did we? Oh. Dyslexic. Okay. Okay, so let's put 3 into the original. So again, to speed things up, f of 3 equals 3, and f of 1/3 equals negative 6.5. And the other thing I want to just say is that we are increasing over the interval 1/3, comma 3, and I'm decreasing negative infinity to 1/3 union 3 to infinity. Okay, so I want this, and I've got to make sure I'm doing that. Any more mistakes before I go on? It's a tough crowd. Okay, so let's do this. I know I'm starting. Okay, so if I got this, okay, make sure I'm starting here, ending here. I have got 0, negative 6 is going to be my y int, right? So, okay, so I'm going to go negative 2, negative 4, negative 6. So that's my y int. Again, I'm going to go by 1s here, 2, 3, 4, because my x-intercepts are 2. Maybe just write x int there, and what was my other one? 3.8. So there's 3, so then I got, this is another x int, and negative 0.8. So negative 1 is here, so I'll go there. Okay, I got a min value. Oh, I guess I should have. I kind of had min written on the thing, but this will be my min. This will be my max. So 1/3, comma, negative 6.5. So that's there. So my min. Now that's going to be a local, right? My max is at 3, comma 3. Now I'm going by 2's, right? 2, 4, so 3, comma 3. Be about there. Actually, I'm just right max. Okay. Now, depending how you want to do this too, there is a way that you can talk about your increasing and decreasing. Because from 1/3 to 3, it is increasing, right? So then I would say here's 1/3. So you can go like this if you want. And you can put the decreasing from, I should do this in black. And then we're going to be going like this. And like this. And then later when we do second ribs, we'll maybe put concave downs and ups too, right? Well, sometimes, like you knew this, but when I give you x to the 7th, where's my mouse? Oh, there you are. Okay, you knew this, but it's just, you know, when we get to harder ones, I think it'll make more sense. Sometimes the easier ones, I get it. Maybe it's too much information, but so we're starting from here. So decreasing through that interval. Then from here we are increasing to this interval, and then we are decreasing, and we make sure we put our arrows. Okay, so the question is, do we need to do one more, or are you guys good? I think you're good. Just maybe some quick facts on this one. My first picture should be, you know, doing something like that. Actually, this one's really quick. Oh, no, we should go through this one. It is just a special case, just the factoring. Y int, this would be 0.4. The x int, now this one here, there's always, if this degree is half of this degree, you can treat them just like normal quadratics. Okay? So in this one, you can do what two things add to give me. So I guess if this was x to the 6 and that was x to the 3, you can do the same thing. Okay? So if these two, if that one's ever half, so you're doing what two things add to -5, what two things multiply to 4, -4, -1, right? And then you just make sure that your x's, so this would be x squared minus 4, x squared minus 1. And then what do you see with this one? Difference of squares, so 0 would equal x plus 2, x minus 2, and x plus 1, x minus 1. Okay, so I just want to go through that because that's just kind of one piece of review as well, that if those are all either the second one's ever half the first, then you can do that shortcut instead of looking for all the factors of 4 and getting there anywhere. So this question is actually a lot easier than the last one. Okay, so here is your homework. and the answers are in your book as well.